Okay, kids, we gotta wrap this up quick. My camera keeps saying out of memory storage, you can't do this anymore, and I keep deleting stuff and it keeps doing it, so I gotta go fast, right? I gotta get this done. I know some of you are saying, oh God, thank God, thank God, thank God. Yeah, let's do it, let's get it done, wrap it up. So this is our equation. We're gonna solve for G. We know L, you've got that. Now you've got the time period calculated, total time divided by 20, get time period, solve for G. And we all know it should be 9.8, right? We'll see what you get. Hopefully, we did some good work, you and I, lab partner, because we're good together. We work well together, you and I. We're the best, you and I. We're the best. So let's see if we can come out with 9.8. Do a percent error. That's the last thing here, percent error. Okay, do your percent errors for G. Now, that's trials 1 through 5, percent error for G. Now, for trial 6, you're going to do a percent error for L. This is different, okay? Percent error for L. So we now know the time that it took to go back and forth 20 times that were close to 1. It was close to 1 second. So get that time period. So here's our equation. This time, we're going to solve for L. This is for number 6. Solving for this one right there. Solve for that L. So now get the time period. Okay, it was 19.7 something seconds. Divided by 20. Okay, very close to, it's only 0.97 seconds. It's pretty close to 1. Use that, and then put that in here. Put 9.8 here, we know that's 9.8, and solve for L and see what you come up with. That would be your experimental L. Now, here's what you also want to do. You want to get the true value for L. The true value for L is going to be done by taking time, period, and put a 1 here. Put a 1 there, because we're trying to get 1 second of time period. So put a 1, put 9.8 in here, and then solve for L. And that'll give you the length that you should get a time period of 1 second. That's the true value, whatever that is. I think it's 23 point, I'm trying to remember, 2, somewhere around there. And then what we got, okay, what we got by taking our time period, which was a 19.72, I keep saying 72, I think that's what it was, but hopefully it's closer. And then get your time period that we got in the experiment, okay, take that time, divide by 20, get that time period, 0.9, whatever. And then solve for L, put 9.8 here, solve for L, and see what it comes out to be. And we'll see how close we are. I bet we're going to be really good. You and I are good lab partners, so I bet our percent error on that will be very small. So the true value will be, when you put 1 in here and 9.8 here, solve for L. The experimental value is, put 0.9 blah blah, what we got in the experiment, and 9.8 here and solve for L. And then go ahead and do a percent error on that number 6 for the length. So that's the one that's different. Doing that one for length, 1 through 5 for G. Okay, then to wrap this bad Larry up, so you got 3 questions on the front. A lot of questions in this lab. A lot of questions. This lab is muy cuestionado answerable. I think I'm going to make this worth more than 50 points. I think this lab is going to be maybe worth like 75 points. Yeah. Well, it's a lot of points. Why? Because check it out. Okay, in the front, do this data, do the calculations, figure out these questions. Then, on the back, look at them all. That's a lot of questions to answer. Why? Because these really dive into looking at the equation for pendulums and utilizing it in various situations, and that's what AP loves to do to you. So here's what I've done for you, though. On several of these, not all, but several of these, I already have the answers already done in there for you. Number 3, I have the answer. Number 4, I have the answer. This is the answer. Number 5, I have the answer. So several of these calculations, I have the answer. You need to show me how I got it, how you get it. So you're going to get the answer by solving, doing the math, and coming up with the answer. So you know what the end result should be for those. Show me the work to get there. You can do it. All right, and we have several others. One is draw a free body diagram. There's a pendulum drawing. I'm going to draw a free body diagram for this. Second one, a simple pendulum, blah, blah, blah. What happens? Justify your answer. This one's a question, not a calculation. Calculation, I'll give you the answer. Calculation, I gave you the answer. Calculation, I gave you the answer. And then we have 2 more questions here to round it out. Yeah, it's a lot of questions you got to do. So there's a lot of work involved in here. So I think we're going to crank this bad Larry up to 75 points. That's what it's going to be worth. Yeah, so you don't want to blow this one off. I'm telling you, you want to do it. All right, I think that wraps up the Pendulum Lab. So you know what you have to do. So remember, this is a full lab report too. Remember that? Full lab reports? Yeah, this is a full lab report. And over here, okay, we'll point you over here once again. Okay, data. Okay, got that table. We don't have any graphs. We have the table, so that's our data. Calculations. Okay, we got to calculate. We don't have a table for this because we don't have any graphs. So data and calculations. Okay, we got our calculations table too. Well, there's a calculations table. Error analysis, 2, 1 controlled, 1 uncontrolled. So, what you and I could have done better. What could we have done better, lab partner? Answer the questions. Lots of questions to answer for this lab. Not just like 3 or 4. There was a lot of them. So that's why this lab's going to be worth 75 points instead of 50. So you got lots of work to get done for this bad Larry. I thought you'd like this. I do. You're my favorite AP students I have this year. So I do like you. But tough love, people. Tough love. Okay, that wraps this video up. And the last video of the Pendulum Lab. So I think we're done. I think we're ready to roll here. So you kids have fun, and we'll talk to you soon.